then B is called similarity matrix for A, right? This transformation of matrix A by non-singular matrix M to B is called similarity transformation, right? This is the similarity of matrices, and this transformation is known as similarity transformation, right? Note that if the matrix B is similar to matrix A, then B has the same eigenvalue of as A. Note this is very important result, that if B is similar to matrix A, then B has the same eigenvalues as A. That means if we diagonalize the matrix, then the eigenvalue will be the same, right? So this is the very most important result, very most important note for the eigenvalues, right? So now let us look at the example. The question is, reduce the matrix A 1 minus 1 2 0 2 minus 1 0 0 3 to the diagonal form similarity by similarity transformation, and hence we need to find a cube. So first of all, I have here written the format, that is the characteristic equation, that is 1 minus lambda minus 1 2 0 2 minus lambda minus 1 0 0 3 minus lambda, that is equal to 0, that is determinant of A minus lambda is equal to 0. And by simplifying this one, we will get lambda is equal to 1 2 and 3. So this is again question how this is lambda is equal to 1 2 and 3. So that is very quite and clear answer, that by simplifying the determinant we can find the value of lambda by solving the equation of degree 3, right? So we have 3 value of lambda, that is equal to 1 2 and 3, right? So this is the homework for the students. Using this characteristic equation, student need to find the value lambda is equal to 1 2 and 3, and for this matrix it is quite easy because this is the upper triangular matrix. Okay, so if you know about the upper triangle matrix, if you look at here we have 1 minus lambda minus 1 2 0 2 minus lambda minus 1 0 0 3 minus lambda, that is equal to 0. So note that this is the upper triangular format, right? Because all the elements below the diagonal elements are 0. So now that is quite easy to simplify this format. If we expand the determinant, then I will get 1 minus lambda into, this is 2 minus lambda into 3 minus lambda, this is minus minus plus 0, this is minus minus plus 1 into, this is 0 into 0, this is 0 plus 0, that is 0, again this is plus 2, this is 0, this is 0, so again the bracket will be 0. So all this term will be vanishes, right? All are 0. This is also 0. So after all we will get 1 minus lambda, 2 minus lambda, 3 minus lambda is equal to 0. That means 1 minus lambda is equal to 0, or 2 minus lambda is equal to 0, or 3 minus lambda is equal to 0. So we will get lambda is equal to 1, lambda is equal to 2, lambda is equal to 3. As we have discussed in the PPT, we have not simplified this one in the PPT, that lambda is equal to 1 2 and 3. So in this way we can find the values of lambda, which is the eigenvalues of for these matrices. Okay, so now if we move ahead in this example, we need to find the diagonal form. Okay, so here the eigenvalues of A are 1 2 and 3. Okay, so here the corresponding lambda is equal to 1. First of all we need to find the eigenvectors for all eigenvalues. So we have 3 eigenvalues, lambda is equal to 1, lambda is equal to 2, and lambda is equal to 3. For all these three values we need to find the eigenvector, right? So first of all we will find the eigenvector for lambda is equal to 1. So let x1 is equal to column vector x1, x2, x3 be the eigenvector. Then a minus lambda I into x1, that is equal to 0. Here lambda is equal to 1, so that is a minus I into x1 is equal to 0. So by simplifying we will get 0, minus 1, 2, 0, 1, minus 1, 0, 0, 2, that is a minus I into x1, that is x1, x2, x3, that will be equal to the column vector 0, 0, 0, right? So by simplifying and by solving the matrix equation, we will get minus x2 plus 2x3 is equal to 0, x2 minus x3 is equal to 0, and 2x3 is equal to 0. So if we take x1 is equal to k, then we will get capital X1, that is our first eigenvector, that is equal to k1, 1, 0, 0, right? Because x2 is equal to 0, x3 is equal to 0, and x1 is equal to k, right? So our eigenvector will be k1 into 1, 0, 0. This is our first eigenvector with respect to the first eigenvalue lambda is equal to 1, right? In this way we can find the eigenvector for lambda is equal to 1. In a similar way we also need to find the eigenvector for lambda is equal to 2 as well as for lambda is equal to 3. So let us look at what is the eigenvector for lambda is equal to 2. Corresponding to lambda is equal to 2, that is capital X2, that is equal to the eigenvector for lambda is equal to 2. Then the a minus lambda I, that is a minus 2i into x2 is equal to 0. So here we will get minus 1, minus 1, 2, 0, 0, minus 1, 0, 0, 1 into x1, x2, x3, that is equal to 0, 0, 0. And in the equation form we will get x1 minus x2 plus 2x3 is equal to 0, minus x3 is equal to 0, and x3 is equal to 0. So here we need to take x2 is equal to for example x1 is equal to k2, x2 is equal to, then x2 is equal to minus k2, and here x3 is equal to 0, right? So we will get the eigenvector with respect to lambda is equal to 2 will be x2 is equal to k2 into column vector 1 minus 1, 0. So this is the second eigenvector for the eigenvalue lambda is equal to 2, right? In the same way we will find the eigenvector for lambda is equal to 3. Here let x3 will be the eigenvector, right? Then a minus 3i into x3 is equal to 0. So here the matrix equation will be minus 2, minus 1, 2, 0, minus 1, minus 1, 0, 0, 0 into x1, x2, x3, that is equal to 0, 0, 0. So we have now only two non-zero rows. So we will get only two equations from here. First one is minus 2x1 minus x2 plus 2x3 is equal to 0, and the second one is equal to minus x2 minus x3 is equal to 0. And by simplifying here we need to take say x2 is equal to k3, then x3 is equal to minus k3, and so by simplifying the equation number 1 we will get x1 will be minus 3 by 2 into k3. So taking k3 common we will get x3 is equal to k3 into bracket the column vector 3 minus 2, 2, right? That is the third eigenvector. Okay, so now we have all eigenvectors with respect to three different eigenvalues, that is lambda is equal to 1, lambda is equal to 2, and lambda is equal to 3, and we have now three eigenvectors. By arranging all these three eigenvectors in column size we will get the the vector matrix which we will need. So here if we look at here, we will get here the matrix M, which is model matrix, by arranging all these eigenvector in column wise. So first eigenvector was 1 0 0 for lambda is equal to 1. The second eigenvector for lambda is equal to 2, which was 1 minus 1 0, and the third eigenvector for lambda is equal to 3 is which is 3 minus 2 2, right? And here we need to find M inverse as well. M is the model matrix to do the diagonalization for the matrix A. Here M is, we have find M, we also need to find M inverse, and to find M inverse we also need determinant of M and adjoint of M. So here we also need to expand the determinant and to find the determinant of M. Here I am not explaining how we will find the determinant of M. This is for the check yourself for the students, that is determinant of M will be minus 2. As well as I haven't explained that the adjoint of A will be minus 2 1 0 2 2 0 0 minus 1. So this is again homework for the students to find determinant and adjoint for this model matrix M. After finding the determinant of M and adjoint of M, we can easily find M inverse, that is adjoint of M upon determinant of M. Here determinant is equal to minus 2, so we will get M inverse will be 1 1 minus 1 by 2 0 minus 1 0 0 1 by 2. Okay, that will be the M inverse. So by taking M inverse into A into M, here M inverse is equal to 1 1 minus 1 by 2 0 minus 1 0 0 1 by 2 into, that is A 1 minus 1 2 0 2 minus 1 0 0 3, and this is M, that is 1 1 3 0 minus 1 minus 2 0 0 2. Okay, so by multiplying these three matrices we will get M inverse into A into M. Now how to multiply these three matrices, that all students know, that we can first multiply the first two matrices and then we can do the answer with the third matrices multiplication, or we can first multiply the last two matrices and the resultant matrix will be multiplied by the first matrix, because we can group the matrices for the multiplication, right? So here by multiplying all these matrices we will get the diagonalization of matrix A will be 1 0 0 0 2 0 0 0 3. Note that this is the diagonal matrix of for the matrix A, which is 1 0 0 0 2 0 and 0 0 3. Note that 1 2 and 3 are the eigenvalues for the matrix A. So this is the diagonalization of A, and since D is equal to M inverse into A into M, so here A is equal to M into D into M inverse. That is quite clear by multiplying both sides by M and then M inverse. So we will get A is equal to M into D into M inverse. So if we want to square the matrix, then A square is equal to M D M inverse into M D M inverse. By simplifying we will easily get this one is equal to M D square M inverse, because M inverse into M is equal to Y. This is the property of the inverse of the matrix, that M inverse into M is equal to Y, right? So M into D inverse into D square into M inverse, that is equal to A square. Now this is in the same way we can find A cube is equal to M into D cube into M inverse. We have M inverse, and we have D. D is equal to, that is 1 0 0 0 2 0 and 0 0 3. So we can easily cube D because that is the diagonal matrix. So then the d cube is equal to 100, that is 1 cube, that is 1, 2 cube, that is 8, and 3 cube, that is 27. So 100, 080, and 0027, that is a cube. Okay, so we will get easily a cube using the diagonalization of this matrix. So in this way also we can find a cube using the diagonalization of the matrices. So in this way this is the value of a cube. So here we have discussed how to find the how to diagonalize the matrix using the eigenvalues and eigenvectors. So today we have discussed about the Cayley-Hamilton theorem. Also we have discussed how to use the Cayley-Hamilton theorem to find the inverse of A. Then we have discussed how to diagonalize the matrix, and using the diagonalization how can we find the cube of the matrix or square of the matrix or fourth of the matrix. So this is the very important result for the exam point of view. For the G2 examination, student must remember that there is one example related to Cayley-Hamilton theorem or the diagonalization is there. So this is very most important for the exam point of view. So that's it for this chapter. Thank you very much.